do some limits now from helpmegraduate.com. Visit our website for more information regarding videos of other topics, and of course try to contribute to my cause if you can, okay? So before doing the exercises from my favorite book, I just want to point two key things, right, before starting. The first thing is, when you have a limit, evaluate the limit before doing anything else. I was in this class once, and we had different sections, so the finals were done depending on each professor's taste. Okay, so it wasn't an entire final for the entire faculty, but instead each professor built his own final. And this buddy of mine I knew from hanging around or whatever, he had this limit on this exam, and it looks so typical from the book that you have, you know, those 0 over zeros and determination that you had to do whatever magic you can to try to solve it. Well, he just started scrambling, you know, whatever popped into his mind, multiply this, add this, let's see if I can tweak this a little bit, change more. And he got whatever result he could, but in reality what was happening is that the limit had no indetermination at all. He just had to evaluate the variable x into the function, and that was it. It was just given a real number right away. So of course he ended up giving my friend or my buddy, whatever, just 0 points on the equation because he just basically wasted his time. He did something that wasn't worth it, okay? So the first thing that you have to do when you have a limit is evaluate the variable of x into the function and see if in reality there is an indetermination and there is something that has to be done to the limit to solve it. Among the options, if there is an indetermination, then you have to scan the method according to the limit that you have, okay? There may be many paths in math to solve problems, but there is one thing for sure. There is one path that is a little bit shorter than the other ones, okay? And that's the one you pretty much want to pick, okay? And among the methods we have for limits, we have multiplication with a conjugate, we have add and subtract 1 or a or whatever constant you want to try to build a familiar expression in the limit. You can make a change of variable, which is my preferred strategy, as you may have seen in past videos. You can use notable limits, or you can just simplify, break the polynomial into factors and just evaluate, see if they can cancel each other or something, okay? But again, the main thing is evaluate, and find the indetermination, then scan the methods, okay? Just pause for a second, look at the problem, and see which of these methods may likely take you to the solution of the limit, okay? So I'm going to erase this, and we're going to move on to a couple of examples I want to show you, okay? Well, the first one, let's see, from my favorite book, I'm going to have limit of x tending to 2, and the function is x squared minus 4 over x squared minus 3x plus 2. Okay? So don't worry, I'm going to do it both ways, the quick way and the complicated way, okay? The quick way is just me assuming that you know everything, and that pretty much is a little bit rude on my behalf. The more polite way is me assuming that you want to learn. How is it done? Okay? So, what did we say do first? Evaluate, okay? When we evaluate, we're going to have something like 2 squared minus 4 over 2 squared minus 3 times 2 plus 2. And this right here at the top is 2 squared. 4 minus 4 is 0. And this right here at the bottom is 2 squared minus 3 times 2 is 6 plus 2, 0. So this is an indetermination. Okay? But that means that indeed now we have to scan among the methods that we have and see what we can do to solve the the inquiry of the problem right here. Okay? So, among the methods that we have was conjugate, simplify, polynomial, change a variable. Well, it looks like we have two polynomials right here on the numerator and denominator, and all that we can do is maybe, break them apart. This right here, x squared minus 4, looks like if I had x squared minus a squared. And that is exactly as if I had x minus a, x plus a. So that means that x squared minus 4 is going to be break into x minus 2, x plus 2. Okay? There's the first one. And on the second one, in the denominator, we're going to have x squared minus 3x plus 2. Now this really doesn't look like anything, but we know it's a quadratic function, okay? So we can break it up with a quadratic equation or whatever, okay? So this broken to pieces by the quadratic equation or formula or whatever you want to call it, okay? It's going to look a little bit like the following. Well, we have something like minus b plus minus square root of b squared minus 4ac over 2a, okay? In this case, a is 1, b is minus 3, and c is 2. So, when we solve this, we're going to have 3 minus times minus is 3, plus minus 9 minus 4 times 1 times 2, which is 8. Okay? And then we have 9 minus 8, 1, and the square root of 1 is 1. Okay? So, we have 3 plus minus 1 over 2 times a, which is 2. This means that we're going to have one piece that is going to be 3 plus 1, 2, 4, over 2, 2, and the second one is going to be 3 minus 1, 2, over 2, 1. Remember that the factors are the elements of these little pieces. Okay? As you can see, we have x minus 2 on the denominator and x minus 2 on the upper side of the equation. So we can break them up. Okay? All I'm going to do is erase and just fit those pieces right here on top with a new form. Okay? So with 1 second. I'm going to have limit of x tending to 2. Upper part is going to have x minus 2 times x plus 2. Bottom part is going to have, or lower part is going to have x minus 2 times x minus 1. And I can erase this part. So, now we have simplified, we have rearranged, we have rewritten the function that is being limited. Now we have to make the small observation. If, or since, x is not 2, this means that we can cancel these two out. And then we're going to have limit of x tending to 2 of x plus 2 over x plus 1. Since we got rid of the indetermination, I think it's probably fair enough that we evaluate, because we may have solved the problem. So let's do that. We're going to have evaluating two plus 2, 4, 2 minus 1, 1. And this equals 4. And that is the answer for the exercise. There you go. Pretty simple, pretty straightforward. Let's do another one in another video.